This video we will talk about class relationships. Very important in object-oriented concept, we talk about how to design one class. But in the real world, you know there are many different types of objects. So we should design classes. So to design multiple classes, you need to know the relationship among the classes. The common relationship from classes are association, aggregation, composition, and inheritance. So in this video, we will only talk about the first three. Inheritance is a big topic, so we will talk about next week. The first thing, let's talk about association. Association is a general binary relationship that describes an activity between two classes. So we're using this example in this week. So in our class is COMSC255. We can consider a course is one class. Then we need to have a faculty to teach this class. And also we have students taking the class. So that's why you see here we have the association. So the association is a general relationship. A faculty teach a course. A student take a course. So that's the relationship between two classes. So then sometimes we make them together because one course can be associated with multiple classes. And here actually this one is also a UML diagram. UML diagram can be specific, say for one class that we showed you before, but also they can have the relationship among multiple classes. So here is another way to show the UML diagram. You have a rectangle to represent the class. So we're using the line to show their association. So then here you see the triangle will have the association star. So student take course. And how many students can take the course? So you can see here each course, for example, we have at least 5 students in a class. At most, we have 60. So that's why in the line, you also can show the number of the object to associate with the other type of object. So here we just have students, at least we need to have 5 to 60 students in a course. So then here the course, sometimes if you see if they have the asterisk symbol, that means students, we didn't give them any limitation how many courses they can take. On the other hand, you can see the same thing. The faculty teach a course. So one faculty teach one course. So then a faculty can teach 0 to at most 3 courses. So that's the UML diagram to demonstrate the association. So once we understand the association relationship among student, course, and the faculty, so when we try to implement these 3 courses, so these 3 classes, we also need to consider to demonstrate this relationship in their class implementation. So then we will see the example. In Java code, if you want to implement association, we're using the data field and the method to demonstrate the association relationship. So you can see here, for example, in a student class. So student taking multiple courses. So that's why we create a course array as the private data attribute for the student. So here we're making the array, that means students can take multiple courses. So then you see here, student taking the course, right? We say taking the course, but on the other hand is students to register a course. So that's why here we can add a course. So you add a course, then we will add this course, then we update the course list from the student. You can add a course, of course you can drop the course. So that's what we say we need to using the data attribute and the method to represent the relationship. So you can see faculty will be similar. So the faculty teaching a course. So a faculty can teach multiple courses. So we make a course array is the same thing as a course list. It belongs to a faculty object. Of course, we can add a course, but just students, just faculty, we don't drop course. We may just maybe remove that from the course. So then afterward, you can see here, for each course object, they will have who is their faculty. Because we only have one faculty, so we don't need the array. We just make them as a simple data attribute. So then a course can have 5 to 60 students. So we need to make the array. So then student add the course. Then at the same time, course need to add the student. Then we need to set the faculty. So that's the relationship about the association relationship, how we will implement in the Java code. Here we just simply to talk about the association relationship among course, student, and faculty. So here I have more in detail how to implement the classes about these three classes. So here just demonstrate to show you the more official UML diagram we can write like this. You see we can including the data attribute and the method. So this example I will talk about at the end of this week. So then later after your lab exercise, before you moving forward for your homework assignment, so I will have case study for that. So after the association relationship, the next two about aggregation and composition, they are both represent ownership relationship, but they have a little slightly different. When we talk about association, they just associate between two classes. They don't really have the ownership. But sometimes we do have the ownership. So then we were using aggregation and the composition for that. So the first thing about aggregation actually is a special form of association that also represents an ownership relationship between two objects. So aggregation module has a relationship. The owner object is called aggregating object, and the class we call aggregating class. So this subject object called aggregated object. So what does that mean? So that means if we have one object owned by several other aggregating objects, we call they are aggregated object. For example, student has a name. Student has an address. That's an aggregation relationship between the student class and the address class. So we see here. This one is we say the student class. So you can see student class, student can has the name, right? So you see students own the name one by one. Yeah, so that's why you have your own name. Then your own name is unique. So then you students can have a mailing address. But this mailing address is a physical address. So that's why, for example, your address, you have multiple roommates live in the same address you rent. So that's why you can see here, your student can have an address, but this address is actually owned by more than one student. So this kind of ownership we call aggregation relationship. They are not privately or exclusively owned. So the address, because they are physical address in that household, maybe you have multiple people there. So we don't not only talk about student, maybe we only have one DVC student. But one thing is you have maybe your parents live there. They have their job. So their job contact address, they will be the same. So that's we call the aggregation. So aggregation, we say that's an ownership, but they are not exclusive. So if an object is exclusively owned an aggregating object, we call that a composition relationship. So this composition relationship, for example, like a person, a student has a name. So then that's one-on-one. So then you will say sometimes you have the people with the same name, right? Okay, but be careful. When we say the name here is, we call that like the literal object. Okay, so this literal object maybe content is the same, but exclusively for this student, the name will recreate an object. So that's what we say, for example, did you remember we say the string, you have all the string, they are immutable string. They are immutable object, but sometimes they can have the same content. So this is the meaning for the why we say the name is composition exclusively owned. Because this name, when we create this name object specific for this person. So the same thing when we try to implement aggregation or composition relationship, we implement in a data field. So this data field, for example, a student have a name, a student has an address. So that's why you will see here the name is they have content. So then you have the class student, they have their own name and the address. So that's the aggregation relationship. So the difference is you can see aggregation or composition, we only have the data field for the other class, but they don't really have the association relationship. So association is content both is you have has a relationship, but also you have the association behavior. So that's the method. But aggregation and composition, we are just simply only using the data field to represent. So sometimes aggregation can be exist between objects of the same class. For example, a person may have a supervisor. So then you see a person has a supervisor, but the supervisor is also an employee. Or you see is a person. So that's why sometimes the ownership doesn't need to be between different classes. So if a person has several supervisor, so you can use the array to store the supervisor as well. So that's why sometimes your aggregation and composition, you has multiple value. So then we can use an array to represent for that. So that's the class relationship. We talk about aggregation, composition, and association. So then next week we will continue to talk about inheritance relationship. So this one actually is what I want you to add into your lab exercise 5. So your lab exercise 5 continue with your lab exercise 4. We have lab exercise 4 only have one class, right? So then here in this one, I want you to create multiple classes. So I want you to create at least 2 more classes related to the class you designed from the prior week. So include at least 3 instance variable, 2 static variable, and 2 instance method and 1 static method in each class design. So the same thing, I provide you the UML diagram sample. So then you need to implement all the class.java file and have the main driver. So that's a very interesting lab exercise. You may not really identify correctly about the relationship, but I just want you guys to try. Pick up multiple objects. So then try to think about their relationship among those objects. So then design the classes for the object you target.